So, greetings, Anamita. It is a pleasure to have you with us today on Access by GCL. Together, we hope to gain insightful answers that can benefit newer generations of STEM students. Before diving in, could you share a little bit about your field of work?
Yeah, well, first of all, thank you for having me.
Sure
My
thing.
name is Anamita Guha, and I am the global lead of product management at IBM Quantum. And my role is kind of a marriage of a couple of different roles. So I work at the intersection of product management, growth, and go to market. And in my role, I create new and diverse markets. I lead a globally distributed team. And I also work to create and build inclusive communities that really shape the future of conversation when it comes to technology. So I work at in quantum and I quantum computing, and I hope to get more individuals around the world to understand what quantum computing is, and also for those that are relevant to use quantum computing products by IBM.
Wow, that's such a diverse answer. So, how did you discover your passion for artificial intelligence, quantum computing, and computer science?
Yeah, so it's kind of a longer story.
Mhm.
For me, I was born in India, and I moved around a lot when I was little, and and really I lived in a lot of different places. I lived internationally. I lived in Kansas. I eventually found my way to California, where both my parents worked in technology. And for me, um, I just developed this very early relationship with tech and just online communities. A lot of it was because I didn't really fit in at school. So just finding those communities online was really, really great. And I started to create and code online. And by age 9, I was designing websites. And I was designing websites for money. So I didn't have a bank account, but I would get Amazon gift cards as a means of payment.
That's
And
cool.
yeah, and it was really fun, and it really like connected me to different parts of the world, and gave me the sense of belonging and expanded my perspective. I learned so much. And through that, I got very interested in people. I got interested in why humans do what they do, what motivates different people. And I decided to study cognitive science when I was in school. When I went to school, that wasn't really a very well-known major. Now I think it's one of the highest growing majors in the world because of AI. But at that time, it really like naturally translated to AI. And for me, I took a lot of classes in computational models of the mind and applied like probabilistic theories to language and just trying to understand the human brain from more of a technical perspective. And that's where I was very interested. And I started to take the right classes and jump through the right hoops to kind of get me to a place where I'd be excited. And at that time, my excitement was actually going to med school. And I wanted to study psychiatry. And um, the summer before my senior year, I actually founded a company, which was a test prep analytic company. And it was a predictive tool to tell you what to study next based on a previous practice test. And if I was pitching it right now to VCs, I would probably say AI for test prep. But back then, AI wasn't really a buzzword. I worked on it for about a year, sold it, and then I just did a generic search for cognitive science. And I got a job as a product manager. And that's really what started my journey into product management and tech. And over time, I worked at a bunch of different startups, and I eventually found myself at the world's biggest startup, which is IBM. And I started working in Watson. I was running the Watson West incubator. And for me, a lot of it was just bringing back my knowledge and background in AI and learning a lot while I was on the job. And I describe AI as kind of like my first true love.
Yes, that's a great anecdote. Thank you. So you work at a very large company with many different projects currently being worked on. So as a project manager, how do you contribute to the daily operations of the organization?
Yeah, so I'm a product manager, and product management takes different roles at different companies. So when you look, I tell all my mentees when they're looking for new roles, understand what product management is at different companies. Product management, program management, project management, they're all different and they all take different functions. At IBM, we call it offering management, which is you're in charge of not one specific product, but you're in charge of an offering of products. So your scope is very, very large. And the way I think of it and how it applies to like day-to-day operations is that there really isn't, right? You just have to kind of understand the different touch points and be able to communicate with the different touch points. So if you're talking to someone in finance, understand their language and understand how you communicate with them. If you're talking to someone in marketing, you understand their language and communicate with them. Same thing with legal, same thing with engineering. So as a product manager, your role is to really communicate with as many people and make sure that they understand your goals and your vision and what you're building, and then also align it with everyone else's goals and missions and their what they're trying to accomplish. So the way that we really keep day-to-day operations just kind of like in sync is a lot of communicating with each other and finding the right ways to communicate and finding the right methods to communicate, whether it's through Slack or phone calls or emails, and then making sure that everyone's in sync in that way. The other thing is probably being the voice of the user and the customer. So I spend a lot of time with individuals that use our products or individuals that potentially could use our products, and then taking that information and adapting it in a way that others will understand and also prioritize.
Of course, yes. So AI and quantum computing are emerging technologies on the frontier of tech research. So how would you explain these fields to someone who does not know much about the study of computer science and these emerging fields?
Yeah. So for me, when I start explaining these topics, it's very, very important that you explain it in the right way, because there's sometimes a fear associated with the unknown, and you don't want that fear. So what I try to do is I try to find something that individual is connected to. So a lot of times I'll start off with something like, do you drink coffee? And then if the person says, yeah, I talk about how the caffeine molecule has never been simulated by a classical computer. And I go into descriptions of how a quantum computer works and why this is important. Same thing with AI. I'll talk about maybe like helping identify certain things in their life that probably has AI and they don't know what it is. So that's usually how I go about it. And there's many different ways to explain tech like AI and quantum computing.
Yes.
And then I think it depends on who it is. Like if it's a grandma or a 5-year-old, like my grandma's pretty technical, so she gets it. But like just understanding who they are and then explaining it in a way that they understand. But in general, I think of AI as not artificial intelligence, but augmented intelligence. It's there to help you. And it's there to either make things faster, more efficient, and really help you do something, augment what you're doing in a way that makes you more effective or more efficient. So that's AI. I explained quantum computing as it's a completely new type of technology. So there's not really a parallel to what it is in classical computing. And I also place an emphasis on, we're pretty far away from quantum computing being realized for like general usage. Think of it as that we're in like the 1940s of classical computers. So we still have a long way to go. We're making a lot of changes and or lots of advancement quickly, but think of quantum computing as a fundamentally different type of computer, runs on totally different mechanics, and it's going to be a while till you might be used for it. There's also an overlap with quantum computing and AI, which is where I work. So what does that overlap look like? I sometimes explain. So there's AI in quantum, where you will use AI to make your quantum computing research faster. There's quantum in AI. So how do you use a quantum computer to create new algorithms for AI? And then there's AI and quantum, where you are kind of working with it together and do like advancing research and working on different things.
Yes, yeah, those terms made it much more realistic and like more understanding. Thank you. So, so sometimes people are hesitant to learn about how technology and computers work because they're afraid of being confused, like you mentioned earlier. So your work in AI and quantum computing is especially daunting to some. How would you explain your role in technology in some simple words?
Yeah, well, first I'd like to challenge even you to not use words like daunting, because the way we talk about technology right now will influence how we use it in the future.
Of course.
And I think like the language we choose is very, very important. And it goes down to many different layers. Like language will affect your perception of it. For
Yes.
me, the way I like to break it down is that there's a quantum scientist in all of us, and there's technology being used around us. Like, and every time there's a new point of technology, there's a fear associated with it. For example, when fire alarms were invented, it actually took people out of their jobs. Like
Mhm.
before, there would be actual humans that would sit on floors and they would like make noise. So
Yes.
when fire alarms came, that that changed. And so anytime there's new technology that actually fundamentally will change how the world is. So I kind of bring it back to perspective in that sense. Like there's always going to be problems to be solved in the world,
Mhm.
and as there are problems to be solved, new technology is actually a good thing because it will free you up to start thinking about those problems and actually make the world a better place. I'm definitely a tech optimist, so I frame it in that sense, and then I encourage others to be a part of the conversation. So if it does scare you, understanding why, and then finding ways that they can also join the conversation so they can help create and co-create this future that is potentially less daunting.
Yes, I agree. Looking at it as less of confusing and using our perspective to look at it as more of a helpful usage in our everyday life is making it more like normal and more like
Mhm.
something to be interested about. Yes.
Yeah.
So you work at a company known to develop cutting edge technology with the ability to impact many people around the world. However, problems are always present, especially at a large company. From your perspective, what types of problems do employees need to solve? Like, how do they use principles of computing to solve these problems, or AI and other computer science principles?
Yeah. So I think I'll also take this question and reframe it back at you. It's not just little big companies, it's just life, right? So
Yes.
how do you optimize your life and what are you optimizing for? So in the morning when you wake up, you kind of backtrack. This is how long it'll take me to have breakfast and get ready and pack my bag. Or at night, this is my nighttime routine. Or when you go to the grocery store, what are the different things you need and how do you walk through the grocery store to pick up the things you need? Do you like make 5 circles and then pick up an apple and make another 5 circles and pick up your bananas? Or do you pick up the apples and bananas and then go to the frozen section and then come back to the cheese section? So you're doing this all the time.
Yes.
And if you think of everything and you break it down, it's math, right? So you're calculating what you're going to spend your time on or how you're going to go through certain steps. Same thing applies to work. So how can, like, you find problems and you solve it, and how do you solve those problems? And that could be through like algorithms you're creating for yourself that works for you to save time, or algorithms that you do to help ensure that you get the best of something. So maybe you walk around 5 times because they're restocking the apples, and if you walk around 5 times, that's the amount of time it takes for new apples, right? So it's like,
Mhm.
what are you optimizing for? So when you take that analogy and you apply it to your day-to-day job, is it you're trying to optimize for less meetings? Are you optimizing for like more streamlined communication? Are you doing it for faster like A to B development? Are you doing it for more experimentation? So just understanding what the problem is and what you're trying to solve, and then applying your like daily compute principles, which is basically simple math, um, that allow you to get there. So it's not just at work, but it's like you're doing this everywhere all the time. And as a human being, our brains are created to do the less work as possible. We're all lazy by nature. So
Yes.
how do you kind of capitalize on that? And it
Mhm.
goes back to the AI concept of augmenting intelligence. So how do you augment your daily life, whether at
Mhm.
work or outside of work?
Yes, always trying to be more efficient and trying to get more tasks done.
or not. Maybe you just want to laze and that's what you want to do.
Yes, yes, yeah. The other
Your task is just being lazy.
Yeah, it can be taken the other way as well. You're correct.
Yeah, or reframing the lazy to be, self-care.
Mm-hmm.
It's a good
Yes,
thing.
yes. So, where do you see your field going in the next 10 years? You kind of hinted at this earlier, but like, what advancements would you like to see?
Yeah, it's a great question. So I think for me, there's obviously going to be a lot of development in hardware, quantum computing. What makes quantum computing truly unique from anything else I've ever worked on is that the advancements in the software and in the technology and in the field is truly dependent on the advancement in the hardware. And there's different bets that are being made right now of what type of hardware is going to be successful. And this goes down to the qubit level. So if you think about a quantum device, there's qubits, which is roughly translates to what chips are, but they're not the same thing.
Yes.
Like I said, there's not really a parallel. So just understanding how those are designed and how those can be optimized and how those can be entangled with others, and then how they interact with each other to give you reads. So having those advancements is really going to be what's going to drive the future and impact where we will be as a field. And then I think the other thing is just education. I think it's really, really important to see how the next generation trains for this potentially quantum future or AI future. So what classes you're taking at school, what sort of products you're using, and what sort of careers you end up picking. So like training the next workforce, I think is going to be very important. So I feel like for the next 10 years, I'd love to see advancement in the hardware. And then I'd love to see advancement in education so that the right people, whether it's new students, recent grads, or even just career changers, encore careers, or enthusiasts are empowered with the knowledge that they can go use AI or quantum computing in their current work, or figure out how it works, so that when it becomes more of a reality, they're able to kind of say like, yes, I'm a part of this conversation, and it gets you ahead of, you use the word daunting, it gets you ahead of this like new daunting future of where maybe you fear that this is going to take away your jobs, or this is going to be something very, very scary.
Yes, I agree. The next generation of students should, yes, I agree that the education is it's a vital part of this whole process.
Mm-hmm.
So, what advice would you give to the next generation of individuals who want to be in your field? Like you said, like those willing to educate themselves in this field of quantum computing and AI.
Yeah, so I think my biggest advice is to just try it. I think there's something for everyone. So in quantum computing, we're seeing that whatever you're an expert in, you can translate it to the field of quantum computing. So are you a expert in social media? We need people to talk about quantum computing on social media, and we need people to be influencers, and we need people that understand that space. Are you an expert in running events and coordinating humans, right? Then we need people that are going to run quantum computing events. So it's just, what are you an expert in? And if you're working, like, what's a problem in the world that you're interested in, whether it's climate change or like something very simple of like optimizing, I guess nothing is very simple, but like optimizing financial risk, like what sort of industries and things are you interested in? And then think about how you can use AI and quantum computing in that space. So I think what makes quantum computing AI truly unique is the intersectionality of it with other things. So like find a problem or find an industry, find something you're an expert in, and then draw a Venn diagram of what that could look like with AI or quantum computing, and then play around with what's there. The world is becoming smaller and smaller with access to technology, and talk to people that are in the field, find mentors, find people that are learning in public, learn in public yourself. But really, like, I think that triple Venn diagram is where I would say like start, and then figure out what the next step is, whether it's reaching out to other people, reading books, sharing what you learn.
Yes. And finally, just kind of like as a general inquiry, what do you think is what do you personally think is the biggest milestone of your career in AI and quantum computing?
Ooh, what a great question. I don't know. I have a couple of things that are coming to mind.
Hmm.
Um, I think one is my decision to not pursue medicine and pursue tech was probably a big um, career pivot.
Hmm.
Um, and perhaps another one is my transition from going from an individual contributor to becoming a manager,
Yes.
and a coach and a leader. And I think that was a career touch point.
Hmm.
And I think like what's unique about both is how I carried myself and how I kind of reframed my actions in both those instances has probably been the more like impactful things in my career, but also for others, like how I was able to interact with others, learn from others, share with others, coach others, mentor others, and also be mentored myself.
Yes, yes, that is great. Yeah. So thank you so much for your answers. They were really intriguing and insightful. We are very happy to have you, and we hope to see you again soon.
Yeah, thank you for having me. And
Mhm.
for anyone that like has a question or wants to stay in touch, I'm pretty active on social media myself. So feel free to follow me at Anamita G at Twitter. Um, my Instagram, I don't really use it as often, but that exists. LinkedIn, and if I could
Yes,
be a resource for any of you related to quantum computing or AI, I'm happy to help.
yes. Thank you.